Hey, welcome back for part two here. What we're going to do next is multiply two imaginary numbers. And let's see what happens if you multiply two imaginary numbers. Alright, so we're multiplying bi times ci. So you could just multiply the two real parts, bc, and then you have I squared. Now remember what I squared is equal to. I squared is equal to -1, okay? Because I itself is equal to the square root of -1. Alright, so just make sure you got this connection down. I is equal to the square root of -1, so I squared is equal to -1. So we can just make that into -1, and so anytime you get I squared, you just make it into a -1 when you're multiplying imaginary numbers. Alright, and that's really, really important. Now, if you're multiplying two complex numbers in the form a plus bi, we are going to simply FOIL them, first, outer, inner, last. So we're going to multiply here first, 3i times 8i. Okay, now we're not going to FOIL these because it's not a plus bi. Okay, here we're just going to do 3 times 8 and I times I. Okay, so we have 25i squared, and now remember I squared, that's the same as -1. So we end up with -24 in the end. Okay, now here we got a complex number times a complex number. Alright, so what we're going to do is FOIL this. So multiply the first terms, which are 3 times 2. Multiply the outside, that's 3 times -4i. Multiply the inside, that is -7i times 2. And then the last terms, -7i times 4i. Okay, so first, outer, inner, last. And then look what happens when we do the last terms multiplied together here. We end up with 28i squared. Okay, now remember that I squared, that's equal to -1. Okay, so we just make that I squared into -1. Here I just combine these two like term i's. Okay, these two I terms. So -12i minus 14i. Okay, the signs are the same, so we add the numbers and we keep the sign. Alright, and next we can combine these two real numbers here after we multiply by the -1. And so there we have it. There's our new complex number that we would get. Okay, so what I would like you guys to do, one of the second try it problem for you is simply to FOIL, okay, these two complex numbers together, to multiply the two of them. We're going to do 5 plus 3i times 4 minus 7i. Okay, so I want you to go ahead and multiply these. This is your second you try one. So I'll post the answer to this tomorrow, or well, whenever I make the next video. Alright, so let's keep rolling. Next thing we're going to learn how to do is divide complex numbers. But before we get to that, we need to learn about something called the complex conjugate. Okay, so the complex conjugate of a number, of a complex number that's of the form a plus bi, is just a minus bi. Okay, and that's just a little symbol that means complex conjugate here. I typically don't use that, but anyhow. So you want to keep the real part the same, only change the sign in front of the imaginary bi part. Okay, so we'll take a look at that here. Alright, so let me give you a real quick example of what we're talking about then with the conjugate. Alright, so if you have like 4 plus 2i, okay, the conjugate of that would simply be 4 minus 2i. That'd be the complex conjugate of it. Okay, so anytime we multiply a complex number and its conjugate together, the cool thing about this is the imaginary part goes away. And that's why it becomes a really, really useful thing, because you can actually get rid of the imaginary part when you multiply it by its conjugate. Okay? So if we multiply these two together, the shortcut is it will become a squared plus b squared. Now, why? Let me show you. Okay, so remember when you're multiplying two conjugate complex numbers, we FOIL. Okay, so let's FOIL this. We have a squared, that's the f, The outer term would be minus ABI. The inner term is plus BIA, or guess what? ABI. And so those two terms cancel out. Bye-bye. Now the last terms are BI times negative BI. Okay. So BI times negative BI is negative BI times I is I squared. So we have negative BI squared. Now remember what I squared is, negative 1. So I said the middle two terms cancel. Then we would have negative B times that I squared becomes negative 1. And so, whoops, I missed a sign there. When I take BI times negative BI, that's B times B. So that's actually B squared. Okay, so this should be B squared here. My bad. Okay, anyhow, A squared minus B squared times negative 1 is equal to A squared plus B squared, because these two negatives make a plus sign. All right, and so guess what? The imaginary part disappeared, like I was saying. So the shortcut is anytime you multiply a number that's in complex form by its conjugate, it's just A squared plus B squared. All right, so let's check out how this works here next. All right, so here you go. So the complex conjugate of 3 plus 5i, what is it, guys? It is, remember, keep the real part, so that's 3. 3 is still 3. That's a bad color choice. Let me try black. Okay, so it's 3 minus 5i. Okay, so just switch the signs on the imaginary part. All right, so here, this is how you could do it. You could use the shortcut that I just said. It's A squared plus B squared. So A is 3, B is 5 here. So here, we're just going to square A. So A squared is 9 plus B squared. So that's 5 squared. So that's 25. So you get 34. Okay, so you can just skip this part because that's just extra work. So remember, a number times its complex conjugate is A squared plus B squared. Now, that's really useful when it comes to when we are dividing complex numbers. So, when we are dividing complex numbers, we want to write the result in standard complex form. Okay, remember, standard complex form is the form A plus BI. Okay, in order to do so, we can have no i's left in the denominator of a fraction. So we have to get rid of all the i's in the denominator. And in order to do that, we are going to use what we just learned about, the complex conjugate, in order to get rid of the I part in the denominator. So what we need to multiply by, in order to divide this and write it in standard form, is the complex conjugate, okay, which is 4 plus 3i here. Okay, so this is the complex conjugate, okay, right here. Sorry, I abbreviated it because it's hard to write. So it's 4 plus 3i. Okay, we multiply the top and bottom by it, because really when you multiply the top and bottom by it, you're timesing it by 1. Okay, so all this is equivalent to 1. All right, now remember the shortcut that I just taught you guys. When we multiply a number by its complex conjugate, it is just A squared plus B squared. Okay, so here A is 4 and B is 3. Okay, now you could say B is negative 3, but it doesn't really matter, because if you square negative 3, you get the same thing as if you square positive 3. All right, so anyhow, you're going to get 4 squared on the bottom here plus 3 squared on the bottom. And on the top, we're just going to distribute the 2. So it'd be 2 times 4 and 2 times 3i. So we have 8 plus 6i. Okay, now we're going to square this and combine it. Let's see if I can have any more slides to come forward. Oops, there they are. So we would have 8 plus 6i over 16 plus 9, or 8 plus 6i over 25. Now when you have two terms over one term, okay, you can split it up and write it both over the same denominator. Okay, and so there you go. This is the complex conjugate form, standard form, a plus bi. All right, and here is the last you try problem. I want you guys to go ahead and try this one. Just kind of do it just like the one we just did. And yeah, just post your answer there. If you get it wrong, it's okay. I just want you to try it. We'll go over it tomorrow. There's another practice one here, but you don't have to worry about that one. You can try that one if you want to, but we're going to go over that one on Thursday, actually, because there's catch-up day tomorrow. All right. Well, so here's the third problem that you need to submit, and hope you guys have a great rest of the day. And thank you for doing your test on time, most of you guys. And take care. I'll be praying for you guys. God bless. Bye-bye.